So a few weeks back, I had a coil designed for my attempt at an MRI machine. And as you can see from that project, I did not have a good way to measure the homogeneity of the coils, basically, of the magnetic fields, just to make sure that, things are pointed in the right direction. So I had an idea. What if I use the wand again, the BNO 055 9-axis, three of those axes being the magnetic field, and then combine that with the position tracking abilities of the Oculus. Basically, this guy always knows where this guy is, so if I can pull the information of this guy and combine it with this guy, I could probably have a pretty good map. So let's try it out. Okay, so now for everyone's favorite math thing, parametrization. So the idea is that we have to use some math to figure out where the magnetometer will be with respect to the information that the controller is giving us. And so I was playing around with it, and so imagine this is the controller picture. Basically, from your point of view, the left and right is the x, and going right from my point of view, so left and from your point of view, that's the positive direction, and then up is the y, and then forward from your point of view is the z direction. So I just kind of threw this together. Here's the Raspberry Pi. It's connected via cable over to the BNO magnetometer, and then obviously here's the controller, and then I taped it so that it tries to follow the straight line. There's a kind of a crack over here, and there's a crack over here, and it just kind of sits on the right side of that just slightly. So here's the coil I designed a few videos back, and it's gonna have to go in here. I sized it so that it would fit between the polarization and the transceiver coils, like around there. Alright, it's in there. I'm keeping it around 1 amp, as it's about 1.5 amps when it starts getting warm. So the Unity side, the script that's running on the Oculus, is kind of like the last one that I had for the Oculus, where we were going from magnetometer to the VR world. It's a little simpler though this time. I found an easier way to do it. Alright, so we'll start here in the client part, the main thread. The main thread is responsible for finding the right hand object. It starts up the socket, the web service, and another thing that it does is it creates this shared data and passes it to the web service right here, web server. And so that way we can pass the hand position and hand rotation. That's what's in the shared data. And yeah, that's about it. And then I guess the other thing that's happening is the shared data information is constantly being updated from the VR world. Meanwhile, on the server side, we have a local shared data thing, and there is a method which grabs that shared data, and that grabs the main shared data that they're sharing. I know that gets confusing because they all have shared data, and it puts it into this shared data, so like the local shared data. And yeah, from there you're basically just while on message, every time you get a message, you're like, hey, I just got a message. What do? I grab the shared data and I send it out. And here's the send, and that's about it. I also have this other Python code which changes the raw data, the positions from the controllers and the magnetometer, and converts it into something that we can graph, and it's basically just a bunch of vector algebra and plotting. I added a piece of tape to the light sensor on the headset. That way I can put it down and it won't just automatically turn off. Okay, so I've got the Oculus here, and dog over there. That's very important. I put it on a stand because I think it lasts longer if it's a little higher up. And it's got the tape on it. There it is. And there's this wire coming over here for the Raspberry Pi, which is on the wand. And it's kind of hanging by cables. I probably need to fix that. And then that goes in here. And I can just move that around. And I'll be getting the position data. I guess I should probably not stand in the way. And then while I'm doing all of that, I am actually just running... Okay, so I'm running the script through the Unity engine directly onto the Oculus. I'm debugging mode. And then this window right here that you're seeing move with a lot of numbers is the position data from the controller from the Oculus Rift. And then I got another 3 numbers. It seems to have stopped. That's odd. Anyways, I got another 3 numbers from the angle, and then the last 3 numbers are magnetometer data, and all of that is being saved. And there's one more thing I forgot to say, is that when I actually do the full test, I'll also be turning on the fields by running current through it from this power supply. Okay, hopefully this isn't too hard to look at. What you're looking at right now are the red points are the position coordinates, and the blue points are the magnetic field coordinates. And so I guess this is what it looked like from the side. So basically the device was on the table at here at the bottom. I picked it up, I put it into the tube, and then I pulled it out of the tube, and then I put it back down. And then if we look at it from the top, we can see that the way my magnetic fields are set up, on one side of the tube, I'm getting a strong field in one direction. On the other side of the tube, we're getting a strong field in the other direction. The question is, how do we quantize this? How do we get useful information out of it? I think what I need to do is rotate all the data so that I have this in one direction, and then make a plot of the strength of the field versus the direction, how far I've gone in a certain direction. And I think that'll give me a pretty good reading of how homogeneous the gradient is in this area, because that's the important part about this coil. So the x-axis is the axial axis in the tube. So like you can see that trajectory of me putting the wand into the tube and then pulling it out of the tube. And then the y-axis here is the magnetic field. So you can see that when I'm on one end of the tube, I'm at a strong negative, and when I'm at the other end of the tube, I'm at a strong positive. And it's a bit sinusoidal, which you could expect from this kind of gradient coil, but I mean, look at that area in the middle. It's like could you ask for anything more flat? That is amazing. So yeah, overall it worked out pretty well. I found that the gradient, so if I have a tube, and ideally what I would want in the tube is the magnetic field to be high on one side and then like oppositely low on the other side, and then like a good smooth gradient all the way down, and that's kind of what I found in the data. And then left and right, like each disc should be about the same strength field, and I found it had about 10% variation from like the center to the outside, which I don't know if that's great or not. I guess I'll find out later when I'm actually doing the MRI stuff. But for now, it sounds pretty good. The accuracy position of the controller is supposedly 1.6 centimeters, so it could be better, but for something that costs hundreds of dollars instead of thousands of dollars, I think it's pretty good. And yeah, stay crunchy.